In this video, we will talk about coterminal angles. Coterminal angles are angles in standard position that have the same initial side and the same terminal side. Let me show you examples of three different angles that are coterminal with each other. The first angle will have the measure of 150 degrees. The second one, negative 210 degrees. And the third one, 510 degrees. Let's start by drawing the angle of 150 degrees. For this, we need the rectangular coordinate system. And because this is an angle in standard position, the initial side has to be on the positive x-axis. So let's draw the initial side. And because this is a positive angle, from the initial side we will move counterclockwise. And the terminal side will be located in quadrant 2. So this angle measures 150 degrees. Now let's graph the angle of negative 210 degrees. Again, the initial side will be on the positive x-axis. And because we have a negative angle, from the initial side we will move clockwise. Now, before we draw this angle, if it helps, we can break down negative 210 degrees into negative 180 degrees, which is half of a rotation, and another negative 30 degrees. So, to draw the angle, we will move clockwise 180 degrees and another 30 degrees. Then the terminal side will be in quadrant 2. So look at these two angles. They don't have the same measure, but they both have the same initial side and the same terminal side. Then we say that these two angles are coterminal with each other. Now let's draw the third angle. This angle is positive and it's more than 360 degrees, and it would be convenient if we rewrite it as a sum of 360 degrees and another 150 degrees. Then when we draw this angle, we will know that we have to go around one full rotation and another 150 degrees. So let's start with the initial side that is on the positive x-axis. And now we will go around one full rotation and another 150 degrees. Then the terminal side again will be in quadrant 2. Now look at all these three angles. They all have the same initial side and the same terminal side. Therefore, they are coterminal angles with each other. And now, before we move on, do you see how in these two examples I split the angles into a sum of two smaller angles? And I did this because it is easier to draw smaller angles. But how do I know exactly how to split these numbers? Usually I am looking for either one full rotation plus whatever is left, or half of a rotation and whatever is left. Now let's discuss the following question. If we are given a certain angle, for example the angle of 150 degrees, then how many angles can we find that are coterminal with this angle? The answer is that there would be infinite many coterminal angles. To get any of these coterminal angles, we need to add or subtract 360 degrees as many times as we need. For example, if we take 150 degrees and we add 360, we will get 510 degrees. And we already know that 510 degrees is coterminal with 150 because it has the same initial side and the same terminal side. We can also take 150 degrees and add 360 degrees twice, or 360 degrees multiplied by 2. Then we will get an angle that measures 870 degrees. Now let's draw this angle. We will start with the initial side. Then we will move counterclockwise and we will complete two full rotations plus another 150. So here we have one complete rotation or revolution. then another complete rotation, and another 150 degrees. And now we can draw the terminal side. And as you see, just like in the angles above, we ended up in the same spot. Now we can also get coterminal angles if we subtract 360 degrees as many times as we need. For example, 150 degrees minus 360 degrees equals negative 210 degrees. And this is the angle that you see above. Now, what if we want to subtract 360 degrees twice? Then we will have 150 minus 360 degrees multiplied by 2. Then we will get negative 570 degrees. Now let's draw this angle too. First, we will start with the initial side. Then, because this is a negative angle, we will move clockwise. And for convenience, I will split this angle into negative 360 degrees and another negative 210 degrees. So let's move clockwise and have one full rotation and another 210 degrees. And now we will draw the terminal side. And now all the angles that we see here are coterminal with each other. So to find the coterminal angle in degrees, we add or subtract 360 degrees multiplied by n, where n is an integer. But to find a coterminal angle in radians, we add or subtract 2 pi multiplied by n, where n again is an integer. Recall that 2 pi radians is the same as 360 degrees. Now let's see a few more examples where we will find coterminal angles in degrees and in radians. In the first example, we will start with an angle of 60 degrees, and let's also draw this angle. The initial side will be on the x-axis, and the terminal side will be in quadrant 1. Now let's find one positive and one negative angle that will be coterminal with the given angle. For this, we will start with 60 degrees, and we will add 360 degrees as many times as we want. If we just add it once, then we will get the angle of 420 degrees. To draw this angle in the same rectangular coordinate system, we will start with the same initial side. Then we will move counterclockwise one full rotation plus another 60 degrees. And now to get a negative angle, we can take 60 degrees and subtract 360 as many times as we want. If we subtract it just once, we will get the angle of negative 300 degrees. To draw this angle, we will move clockwise, and this angle will have the same terminal side as the other two angles. So the angles of 60 degrees, 420 degrees, and negative 300 degrees are all coterminal with each other. Now let's see how we can find coterminal angles in radians. We will start with the angle of pi over 6 radians. Let's draw the angle, and the initial side will be on the positive x-axis, and the terminal side will be in quadrant 1. If we would convert this angle to degrees, then it would be 30 degrees. In this example, we will also find a positive and a negative coterminal angle. To get a positive coterminal angle, we will start with pi over 6 and we will add 2 pi. And again, we can add this 2 pi as many times as we want. I will add it just once, and now to add, we have to get the same denominator. So let's rewrite this as pi over 6 plus 2 pi over 1. And now the least common denominator is 6, so we will multiply the numerator and the denominator of this fraction by 6. Then we will have pi over 6 plus 12 pi over 6, which makes 13 pi over 6. To draw this angle, we will go counterclockwise 1 rotation and then another pi over 6. And now let's find a negative angle that will be coterminal with pi over 6. For this, we will subtract 2 pi or 2 pi times any integer, for example, times 2. Then we will rewrite this as pi over 6 minus 4 pi over 1. Again, the least common denominator is 6, so we will multiply the numerator and the denominator of the second fraction by 6. Then we will have pi over 6 minus 24 pi over 6. And in the numerator, 1 pi minus 24 pi is negative 23 pi. Then we will have negative 23 pi over 6. This is a negative angle, and to draw it, we have to move clockwise. Now, because this angle is more than one full rotation, let me show you one way how you can split the angle. We know that one full rotation is 2 pi. Now, this fraction has the denominator of 6, and if in the numerator I would have 12, then 12 divided by 6 would give us 2. So the first fraction in the splitting will be negative 12 pi over 6. This represents one full clockwise rotation because negative 12 pi divided by 6 is negative 2 pi. But then we are also left with negative 11 pi over 6. So now on the graph, if we start with the initial side, we will go clockwise one full rotation plus another 11 pi over 6. We can also think of this angle as 2 full clockwise rotations and a pi over 6 into the counterclockwise direction. That is, we would have one full rotation and another full rotation, and then we would go back pi over 6. And now we can say that the angles of pi over 6 radians, 13 pi over 6 radians, and negative 23 pi over 6 radians are all coterminal angles with each other. I hope you enjoyed the video. Please subscribe and thank you for watching.